So now that we've understood the concept of distance and displacement, let's do some question based on it. So see, calculate the distance and displacement in the following cases. So let's begin. Over here we're given point A to point B. This straight line is 10 meters. So see, whenever you want to find distance, look at the length of the actual path. So length of the actual path is 10 meters. So I'll write down over here distance. Instead of writing entire distance, just write D is equal to 10 meters. Now, whenever you want to find displacement, all you have to do is identify the initial and final points. So see, what is the initial point? A. What is the final point? B. Now join the initial and final point by a straight line. So basically we get the same straight line. What is the length of this line? 10 meters. So how do we denote displacement? By S. So displacement is 10 meters. I repeat here, S stands for displacement and D over here stands for distance. So this over here is displacement and here D stands for distance to avoid any confusion. So going forward, D will mean distance and S will mean displacement. Also, whenever we talk about displacement, we have to mention the direction. So there are multiple ways I can do it. I can say 10 meters along AB. I can also say 10 meters to the right of A. So instead of doing all that, we'll just assume right of A is positive, left of A is negative. So right of A is positive, hence positive 10. So I'll just put a plus 10 meters over here. If no sign is there, also means plus. But if you want, you can put a plus over here, meaning it is 10 meters to the right of A. Is this clear? Now, moving on to the next question. Here the person is going from A to B and then from B to C. See, this over here is the same point, guys. Don't get confused. It is just B over here. So he's going from A to B and B to C. So what is the distance traveled? First you go from A to B, that is 10 meters. Then you go from B to C, that is another 3 meters. So the distance traveled is 13 meters. Is this clear? Now to find the displacement, what do? What is the initial point? A. What is the final point? C. Join A and C by a straight line. Now my question to you is, what is the length of this straight line? See, this straight line is 10 meters and this much is 3 meters. So how much remains? 10 minus 3. So this is 7 meters. That means displacement is 7 meters. So displacement is to the right of A, so plus 7 meters. I repeat, how do you calculate displacement? See, initial point, final point, join them by a straight line. So what is this distance over here, guys? This entire distance is 10 meters. This much is 3 meters. So 10 minus 3. So you're now 7 meters away from A. That is your displacement. So as you can see over here, displacement is coming less than distance here. Here it was equal. Moving ahead, coming over here, again the same thing, guys. This is point B only. Do not get confused. So see, let's calculate distance and displacement. So see, what is the distance over here? First you're going from A to B, that is 10 meters. Then you're going from B to A return, that is another 10 meters. So total distance traveled is 10 plus 10, that is 20 meters. I repeat, you go from A to B and come back from B to A along the same straight line path. So distance is 20 meters. Now what is the displacement? What is your initial point? A. What is your final point? It is again A. See, you're back to where you start, right? So initial and final point are the same. So what is the distance between a point from itself? For example, if I'm standing here, what is the distance from this point? 0, right? So displacement is 0. I repeat, displacement is 0. So whenever initial point and final point are the same, displacement will be 0. Why? If 2 points are the same, what is the distance between them? 0, right? If you don't understand this, see, what is the distance between these two markers? It is, let's say, 20 centimeter. Now 10, now 5. Now they're on top of each other, so distance is 0. So whenever initial and final point are the same, displacement is 0. So write down over here, 0 meters, and of course no direction needed because it is 0. Next, come to this question over here. Here, what is the distance? See, you first go from A to B, that is 10 meters. And then you go from B to C, that is an additional 14 meters. So total distance traveled is 24 meters. Now let's calculate the displacement. So see, what is the initial point? It is point A. What is the final point? It is point C. So now this over here is point A, initial point. This over here is final point C. So what is this distance over here, guys? That's what we have to calculate. See, guys, from A to B is 10 meters. So if I draw a vertical line over here, that means this distance will also be 10 meters. I repeat, see, this from A to B distance is 10 meters. So B to A will also be 10 meters. So this is 10. Now the whole thing is 14 and 10 has gone. So what remains? 4 meters. So this over here is 4 meters. So what is the displacement? 4 meters. So around displacement is 4 meters. Now see, I've gone from the right of A to the left of A. So what is my final position? To the left of A. So like I told you, left of the original point is minus. So displacement is minus 4 meters. I repeat guys, why have I put a minus over here? We have gone to the left of the starting point. See, starting point is your origin. Towards the right positive, towards the left negative. So because we have gone left of the starting point, hence minus 4 meters. So this over here is how you calculate distance and displacement. I repeat guys, distance is super simple, just the length of the path. Displacement, identify the initial point, final point, join them by a straight line. Length of this straight line will give you displacement. Now let's observe the values of distance and displacement in each case. Here distance and displacement are equal. Here distance is more than displacement. Here also distance is more than displacement. Here also distance is more than displacement. So what do we conclude? From here we conclude that a very important point, distance will always be either greater or equal to displacement. A very important relation guys. See, displacement can never be more than distance, but distance can be more than displacement. See, here the distance and displacement are same. In all of the three cases, distance is more than displacement. So the only scenario when distance and displacement are the same is when you move in a straight line and you don't change your direction. See, you're moving in a straight line over here, right, without changing your direction. So only in this case, distance and displacement are the same. The moment you change your direction, as you can see, it will start varying. So this is how you calculate basic distance and displacement. And remember guys, distance is always greater than equal to displacement. So right of initial point plus left of initial point minus. So because here we came 4 meters to the left of A, therefore minus 4 meters. So this is how you do basic distance and displacement. So I hope these concepts are clear. Now in the next video, I'll take more complicated questions related to distance and displacement.